Fine. So this length, how much we should draw it? This length we should draw it as 50 mm, right? And now from here we have to take horizontal 60 mm. Okay. So it doesn't matter how much angle he is telling here. It doesn't matter what angle he is telling here. It doesn't matter what angle he is asking here. We can always take this length as 60 mm and then divide this into 6 equal parts. So we can take offset of 10. So 10 mm, 10 mm, 10 mm, 10 mm, 10 mm, 10 mm. So total 60 mm. Got it? So in this, we have to do for the rise. So rise is happening. How the rise is happening? 120-degree rotation. And what kind of motion is there in rising? Diameter of the roller is this much. Draw the profile of the cam. Displacement of the while being raised and lowered is to take place with simple harmonic motion. So both rise and lowering, both are happening with simple harmonic motion. So in this part, we have to draw simple harmonic motion. So take a circle from the center, draw it. So we only need half of this. So take the midpoint of this line, and with that point as center, you have to draw this arc. Then you need to divide this into how many parts? How many parts we need to make? 6 equal parts we need to make. Okay. You can see 6 equal parts I have made. We can do this using a protractor. What is the angle for 6 equal parts?
30 degrees.
Yeah, so 30 degrees you have to take. So each angle, each of these angles is 30 degrees. Okay, so this is 30, this is 30. So all of these angles are 30 degrees. So once you get this, you have to take this first line up to the first point up to first line, and second point up to second line, third up to third, fourth up to fourth, fifth up to fifth, and the last one will go here. Fine. So these are our points. Fine. So first here, second, third, fourth, fifth, okay, fifth, sixth, and seventh. Okay. So this is not required. Okay. Okay. So now these points, if we join them with a spline or smooth line, you will get the curve. Fine. But this is not important for us. The final thing which is important for us is the cam profile. So cam profile we need to draw correctly. In this we can draw whatever angle we want. So here for rising 120 degrees is given, and for lowering 60 degrees given. So we need not draw it as it is. Fine. In fact, the same diagram we can use for rising as well as lowering, because both the motions are happening with SHM. Fine. So if the both motions are same, we just need to draw one diagram and take it in forward and reverse direction. Okay. But if the lowering is happening with a different kind of motion, then we have to draw the graph for that separately. Okay. In this case, it is not required because both are happening with same kind of motion. So next, we need to draw the smallest circle. So here we have been told cam is having minimum radius 25 mm. So I need to draw a circle of radius 25 mm. So this circle is called as the base circle for the cam. It is called the base circle for the cam. Next, it is having a roller follower. It is having a roller follower. And what is the diameter of the roller follower? Okay, roller follower, not just that, but it is also displaced. So here you can see displacement of the wall. Okay. So draw the profile of the cam when the line of the stroke is offset 15 mm from the axis of the camshaft. So now axis of the camshaft will be at the center. This is the axis of the camshaft. Now from this point, there is an offset by 15. So have to draw a circle of 15. Okay. So and the starting point of our follower is lying on this line. Fine. So this is the offset circle. This is the offset circle. This is the smallest radius of the cam profile. It is called as the base circle. And this is the offset circle. Now we need to draw this roller follower. What is the diameter of the roller? It will be given somewhere. Diameter of the roller is 20 mm. Diameter of the roller is 20 mm. And diameter of the camshaft is 25. Minimum radius and the camshaft diameter both are same. So what you have to do is you have to just hatch this part inside. And this you have to keep it as it is. The hatching, in fact, you can do it last at the end. Fine. So let us keep it as it is to avoid confusion. So I have drawn the axis of the this one. Now the diameter of the roller is 20 mm. So for that, what I need to do, I have to take offset of this by 10 mm. So offset of this by 10 mm. Fine. And at this intersection, if I draw diameter 20, it will just intersect this. It will just intersect this exactly. Okay. So we just need to show part of this arc, not the complete arc. Fine. So we just need to cut an arc with this point of center. Distance between these two should be 10 mm. So that gives us the roller. Once we have the roller, we can just show this part, and we can just show the complete follower. Okay, so this is our follower. This is our follower. Fine. So now we need to do the rising. Fine. So the angle is starting at this point. So this point to this point, this is the starting angle. Now for 120 degrees, it needs to rise to the maximum level. Fine. So from here, it's rotating clockwise. Huh? So he's telling, okay, can uniform speed, rotating clockwise at uniform speed. So because it is rotating clockwise, we have to go with this side. Fine. So now we need to take an angle from here of how much? Of 120 degrees. Fine. So from this line, I need to take an angle of 120 degrees. Okay. So once I get this, now I need to divide this into equal number of parts. How many parts do we need? Here we have taken 6 parts, right?
Six,
So
sir.
same, yeah. So here also we need to make 6 parts. So I need to rotate this by an angle of how much? 120 by 6, 20 degrees. Okay. So first take 20 degrees. Fine. Again from here take 20 degrees. Okay. Okay. So at 20 degrees, I need to draw these lines. So this will give me this one. Right. So I think I'll need this circle as well. So let us keep this circle as well. Fine. So from this circle, we need to take the displacements. Fine. So let us go ahead and take the displacements. So now with compass, I need to take this measurement. You can see the radius of this circle is equal to this length, and that length I have to mark it on the first line. So this is the first line, extend it. Now again take your compass back to the next one. Now the next radius is up to here. That radius I need to take on the second line. Go on marking it like that. And the next, the third one. That one is exactly up to half. Go ahead and take it. There it goes. Okay. And then the next one, it's up to this point. So all this what I'm doing here with the circle in AutoCAD, you have to do it with a compass. Okay. So this is over. Next, this one. I have to take it here. Okay. the last one. The last one is here, the maximum rise. So this maximum rise has to come to here. Okay. So this has now rised to the maximum position. Fine. So, but this line, if I join this SPL, if I join this, does it give me the cram profile? Does this give me the cram profile?
No, sir.
No. What is
Only
this?
this ascent, sir.
Yes, no?
Ascent only, sir. This.
Yeah, this is ascent. Ascent is happening with SHM. So all these measurements we have transferred here. But this curve, the red colored curve, this is not the one we have to use. Fine. So cam profile is starting with this circle. This is just the tracing point. This is just the tracing point. So we have to take an offset of this curve downwards. Fine. So in order to do that, you have to copy this circle at all these points. Copy that circle at all these points. So why we are copying the circle at all these points? Because the roller is moving to these points. You know, roller is moving to these points, and cam profile has to touch all the circles. Cam profile has to touch all these circles. Fine. So now this is where I have to start drawing the cam profile. So start drawing this. Okay. So you have to do this carefully. You have to do it in such a way that it just touches all these circles. It just touches all these circles. Tangency should be like this.
Sir, we have to draw tangents to the shaft now, sir.
Yes, ma'am.
We have to draw tangents to the shaft circle.
Yeah, this is the shaft now. This is where the shaft is starting. This is the offset circle.
Offset circle.
Array, yeah, yes. 1 minute. So I made a mistake, big mistake. I have to take offsets at all these points. Only then I can take it. Okay. Right. So now I need to take offsets, right? So next you have to take offset from here. So from all these points, you have to draw tangents to the circle. From all these points, you have to draw tangents to the circle. Okay. So this is very important point. Fine. So many times even this confuses me also. Okay. So these lines are important for us now. Okay. This is the first tangent, next second tangent, third, fourth, and so on. Now the measurements need to be
Sir,
transferred.
then, sir, on paper, how to draw? Sir, means like dash tangents.
You can just keep the scale. Scale you have to keep at this point. Once you get this point, you just have to keep the scale touching this point and touching the circle. Okay.
Okay.
So that way you have to just touch that. Once you have touched all of them, you just need to transfer these lengths. Okay. Just need to transfer these lengths. Okay. Okay. So we have to be careful when offset is given. This is how you have to take. If no offset is given, directly you can take the same lines, the earlier lines directly you can take. Okay. Okay. So this is over. Next, this one. Take this length. Transfer it here. Okay, there it goes. The final one. There. Okay. So this gives us the displacement of the roller. This gives us the displacement of the roller. Once you have the displacement of the roller, what we need to do? We need to copy the roller at all those points. We need to copy the roller at all these points. So you have to draw the circle of diameter equal to roller diameter at all these points. Once you have drawn that, now you can take this point. Okay, so first point is the intersection point here. After that, you have to just carefully draw it. So it should be drawn in such a way that it should come tangential to all those points. Okay. So it should just touch and go. Touch and go. So while drawing, you have to draw it carefully in such a way that it will just touch all these circles. Just touch all the circles. Okay. Fine. So this is our cam profile. This is our cam profile. Next, we have to take okay. I need to take this. Now from this angle, we need to take the next angle. What is the next angle? Next angle is dwell. Okay, so he is telling second point to keep the valve fully raised by next 30 degrees. So from this, you have to go for next 30 degrees. For we have to go next 30 degrees without any rise. So I need to take this, take an angle 30 degrees. Okay. So now again I need to take an tangent line. Fine. Tangent line I need to take, and then because this is remaining at same height, we have to take a circle from this point to this point. Okay, so this has to be a circle with center at the center of cam. Okay. Now from here, for next 60 degrees, it is coming back. So from this line, I need to take another angle of 60 degrees. So take an angle of 60 degrees. Now we need to divide this into again parts. How many parts?
6.
Okay, 6 parts. Fine. So let me take an arc here. So this arc I want to divide into 6 parts. So divide into 6 parts. Divided. So 60 divided into 6, we get 10 degrees each. Correct? Once you get the 10 parts, again you need to draw tangents to the circle. Again you need to draw tangents to the circle. Fine. From all these points, you need tangents to the circle. From this last point, tangent. Fine. So once you get all the tangents, then again, one by one, you need to transfer the lengths. So first length is already transferred. First length is already transferred because it is having the same length, right? And okay. Let us just verify it if it is the same or not. So first length we need to take from here. Fine. So at this point, you will get again the circle. Fine. You will again get the circle. So let's copy this and check. Yeah. So you can see the circle is coming here. It is touching the cam profile. So now it is the first point is correct. Let's go for the second point. So now we have to come in reverse direction because from highest point, we are now slowly coming down one by one. So this is the next one. Let's go for the next one and extend it here. Then go for the next one to here. This line needs to come here. So when you are drawing with compass now, you have to draw large lines, and those large lines, on those large lines, you just have to mark arcs with the compass. Okay. So take this there. Okay. Here. transfer this over here. That's it. Fine. Now that we have got all these lines, we need to again draw circles at all these points. Why we are drawing circles again? We are drawing the rollers. We are drawing the rollers. So now our cam profile should again be touching all these rollers. It should be touching all these rollers. So again, I need a smooth line. I need a smooth line which just touches all of them. So let me just take it like this. Take this, this. Let's check the tangency. Need to take it like this. Fine. So tangency should be maintained. Tangency should be maintained, and it should just touch the rollers. It should just touch the rollers. Because no one is going to measure it over there, you can just draw roughly. So let me increase the thickness. This you can see the profile. Okay. Is it clear?
Yes, sir.
So what you see here is in dark form, that is the cam profile. That is the cam profile. Okay.
Sir, we no need to draw dwell line descent on simple harmonic motion, sir.
Because both rise and lowering, both are happening with simple harmonic now. So we need not show dwell. If both motions are happening with different motion, suppose rise is happening with SHM and lowering is happening with constant acceleration, then we have to draw the lowering also. Okay.
Okay, sir. Okay, sir.
So this diagram is not that important. This diagram we are doing just to get the different displacements, just to get the different displacements. So once you get displacements, you have to transfer it here. So this diagram is more important. This diagram is more important. Okay.
Okay, sir. Means after
How
that
you
there has
taken that
to be
angle, sir? Please, can you say
Sorry.
how you have taken the angles from cam profile 120 degrees of ascent and descent?
So that is given in the question. No, you see the first point, to rise the valve through 50 mm during 120-degree rotation of the cam. So that means 120 for 120-degree angle, it is rising to the highest point. And third point, if you see, to lower the valve during next 60 degrees. That means the valve is coming back, the follower is coming back for 60 degrees of rotation. And in between first point and third point, you can see there is a dwell period. Dwell period is for 30 degrees. Got it?
Yeah, okay, sir. Thank you, sir.
So that's why what I did was I took the first line. Okay. So first line is this one. So from this point to this point, I took 120 degrees. And let me show it. From this line to this line, I took 120 degrees. Then from here to here, it is 30 degrees dwell. And from here to here, 60 degrees. So first I need to take these angles. Then I need to divide this angle into 6 number of parts. And also this angle, it also into 6 number of parts. After taking the divisions from each of these points, I need to draw tangents to the circle. And then I need to transfer the displacements. So you have to
Yes.
carefully watch it. In this question,
Sir, velocity and acceleration.
velocity and acceleration diagram. Which question paper?
Yes, sir. In this one, sir, there are last line they are asking, sir, in that question only, which we are doing.
12th problem, huh?
Yes, sir. Not 12th problem, sir. In the 14th problem only they are asked.
Question
Last
number
line.
14th one.
D.
Okay, what is he asking? Determine maximum acceleration of the wall rod. है ना? So for maximum acceleration, we have done the derivation, no? You have to remember
sir.
that formula. You should
Yes,
remember
sir.
that formula.
After that, sir, then displacement and velocity and acceleration diagram for one complete revolution of scan.
Acha, displacement, velocity, and acceleration diagrams. So
Yes, sir.
displacement, velocity, and acceleration diagrams, it has been clearly explained in this video. Okay. For all the motion, Mr. Ujjwal Rani has explained it very well. I think I have shared this video to you as well, right? So Rani, go to that this video. You can search. What is that? Can SHM cams. Okay.
Things can be smoothened
So you
out
need not draw it
by using
exactly.
a
You just have to
sinusoidal
show how
variation
the
of
velocity is changing.
displacement
Fine.
against
You can see at the top, this is the displacement curve. Getting it?
Yes, sir.
So the topmost curve is displacement curve. Now for the same displacement, we have to show velocity. So velocity is varying like this. Okay. And then the acceleration. You can see acceleration is maximum at the beginning.
Yes,
Then it's reducing to 0. And then it's going to deceleration on the right side. Okay. So these three diagrams you need to draw. Just nature you can draw, and maximum velocity you can calculate and show it here. Calculation formula I have told you, no?
yes, sir. You are good.
So maximum velocity, maximum acceleration, you can calculate and mark them here, and just show the nature of the graph. Only you have to show approximately. That's it. Okay.
Okay, sir.
I'm sharing this in a group just in case you need it. Where is the group? So any other doubts?
Sir, page number 11, question number 14, sir.
Page number 11. Same question paper, same PDF.
Yes, sir.
Page number 11, question number 14. So once again, this is a cam profile. So do you want me to draw it completely, or there is any specific doubt?
No, sir, means how to, because it is not of SHM, no, sir, like that. Because if it is not SHM, how to do it?
If it is not SHM, then the formula will be different. Method of drawing will be different. So how is it happening? Uniform
Yes, sir,
acceleration retardation. So uniform acceleration retardation, I have told you know how to do it. So what is the maximum displacement? Maximum displacement is 25 mm, right? So 25 mm is maximum displacement. Then take offset of 10 mm. So 10, 10, 10, 10. How many times I need to take? 1, 2, 3, 4, 5, 6. So what is the total length? 6 mm, correct? You're getting it?
Yes, sir. 6 mm, sir.
So this is the maximum height, and this is the length I'm taking. So don't worry about the angle. Whatever angle he gives, you always take it as 60 mm. Okay? It will be easy for you.
Okay, sir, that one is confusing.
Okay. So once you draw this, now you have to draw constant acceleration and retardation. So that is a parabola, right?
Yes, sir.
Now divide this middle line into 6 parts, and then join them. So this point you need to join here. This point you need to join here. Fine. Sorry. Here, right? So then you just have to take the points. So first point, second point, third point is here, fourth point here, fifth point here, last point here. Okay. So you just need to join. Join it with a smooth.
So the center line divided by 6 mm, sir.
6 parts. Because this line also we divided into 6 parts, no? So same 6 parts
Yes,
we
sir.
need to make here.
Yes, sir.
Okay. So this is our curve, displacement curve. Okay. And how is it coming back? Return to the initial position. Again, uniform acceleration retardation. Right. So both rise and lowering both are happening with the same uniform retardation acceleration. So you need not draw it again.
Yes.
The same diagram you can use for rising. You can use in forward direction. For lowering, you can take it in reverse direction. Left to right, right to left. That's it. Okay.
Okay, sir. Means these two only they will ask more, sir. Or
Sorry?
there is another means uniform in SHM and then this uniform acceleration and retardation. Is there any another thing, sir?
There is cycloidal. No, cycloidal is very rare. I don't think he will ask it because drawing that is it's complex. Right.
Okay, sir. Means these two
Very
is
rare
enough,
form.
sir.
So these two you prepare it, and also
Okay,
you
sir.
prepare for constant velocity. What is that?
Sir, how to that one, sir,
Yeah.
once.
Sorry,
The displacement diagram for constant velocity.
velocity is simple. Very simple. You just have to draw a straight line. That's it. So suppose you take this. So you just draw a straight line. That's it. This is constant velocity. That's it. Then you just make the 6 divisions. Fine. Make 6 divisions. Fine. And these are the points. So first displacement, second, third, fourth, fifth. Got it?
Okay.
So this is constant velocity. Clear?
Okay, sir.
Yeah. So anyone else having any doubts, you can ask.
Sir, okay. So this session recording, no, sir?
Yeah, this session is getting recorded. I'll share the link.
Okay, sir.
Anyone else having any doubts?
No doubt.
Sir, you have given important questions, sir. In that eighth one, can you explain once shortly, sir?
Eighth one, define the terms, huh?
No, sir. Long from long.
Eighth one. Following data relates to cam profile in which follower moves with uniform acceleration and deceleration during ascent and descent. So same, just now I explained, no? Same thing you have to do. Minimum radius of cam is
So did
25.
you explain the epicyclic gradients?
Sorry?
Epicyclic gradient, the Senville
Epicyclic
problem.
gear train. Fine. So is it clear, ma? Eighth one?
Sir,
Sir, actually height 25 mm, sir.
Height lift is 28 mm. Okay, height is nothing but lift.
Okay, sir.
Okay.
yes, sir.
So
Sir,
this is minimum radius. Minimum radius means base circle radius.
yes.
How to calculate RPM, sir?
RPM will be given, no? You see, it's given here 200 RPM. Right? So based on this
Sir,
200 RPM, we have to find velocity of follower. For that, you have different formulae.
Sir, 11th question.
Yeah, one by one.
sir,
Is
in
it clear?
the
11th.
1 minute here. Let me see if this doubt is cleared. Then we'll go for next. Okay. So eighth question is: are all the doubts cleared?
yes, sir.
Yes, sir.
Okay. So next.
Sir, if they ask slider crank mechanism, then we should write for both single and double, no, sir?
Wait. Let me finish this epicyclic. Then we'll come to that. Okay. So epicyclic gear train. Which one you want?
Ninth one, sir.
Ninth one.
Sir,
Huh?
11th.
Ninth one is here. Ninth one, we have discussed this in class once. Okay, once again I'll explain it. Just a minute. Okay. So there is the question, and diagram is also given. Okay. Right. So here we have epicyclic gear train consists of 3 gears A, B, and C as shown in the figure. The gear A has 84. So A teeth has 84 number of teeth. Okay. And then gear C has how many? 40 external teeth. So 40 external teeth. The gear B meshes with both A and C and is carried on arm EF and rotates about the center A at 30 RPM. So what is rotating at 30 RPM? What is rotating
EF,
at 30?
sir.
Sorry?
EF.
Yeah. So arm EF, which rotates, arm EF, which rotates at 30. That means the speed of the arm, speed of the arm, speed of the arm is given. How much? 30 RPM. So he has not mentioned clockwise or anti-clockwise, so you can just assume it as clockwise. If it is not given, always assume as clockwise. If the gear A is fixed, A means this one. So NA is fixed. That means it is equal to 0. Find the speed of gears B and C. So speed of B we need to find, and speed of C we need to find. Okay. So how to proceed with this? So for such questions, always I told we have to go with the table. Remember, what is the table here? So first we need to take arm, and then we need to take the sun gear. So in this case, the sun gear is C. Then sun gear is meshing with the B gear. Sun gear is meshing with B gear, and then finally the gear A. So first case, we have to keep the arm fixed and give one rotation to the sun gear. When you give one rotation to sun gear, what happens to the other gears? You need to find. So NB by NC equals minus TC by TB. So in this case, NC is equal to 1. So NB will be equal to minus TC by TB. And then we have to find NA. So for finding NA, the ratio NA, it is meshing with NB. That will be equal to TB by TA. Now this one will be positive because it is the meshing is internal meshing. So this one is internal meshing, and hence it is positive. Whereas this is external meshing, and hence we have to take it as negative. Fine, because for external gearing, the direction reverses. But for internal gearing, both the directions remain same. That's why here we have to take positive, and here we have to take negative. Clear? Now this formula comes here. So minus TC by T, sorry, 1 minute. Here it won't come like this. So now for NB, we need to substitute from here. So what happens? NA will be equal to TB by TA, and this NB gets multiplied here, and NB value we know it, that is minus TC by TB. So this TB gets cancelled. We are left with TC by TA. So this is for one rotation. So here what is happening? Arm is fixed. Sun rotates by one revolution. Fine. So this is what happens in the first case. Okay. And then second one, what we have to do? So we have to give X rotations. To sun. So instead of 1 rotation, now we have to make x rotation. So 1 into x becomes x. This also gets multiplied with x. So x times Tc by Tb. And here also x multiplied, x will get multiplied. So x times Tc by Ta. Okay. And finally, what we have to do? Finally, we have to give y rotations. We have to give y rotations to we have to give to the arm. So when you give y rotations to the arm, 0 plus y, it becomes y. Then here this also will rotate with that. So x plus y. This will also rotate by same y. So y gets added. It becomes like this. Here also y gets added. So I'm just writing positive term on the left side. That's it. Okay. So this is our table. This is our table. Once we get the table, we just need to substitute whatever given values are there. Fine. So speed of the arm is given. Speed of the arm. What is the formula for speed of arm? Speed of the arm is given as y. So y has been given as 30 rpm in the question. Now one more speed that is given is na. So write na. Na. What is the formula for na? Na is given by this formula. So substitute. So y minus x times ta by tc by ta. Tc by ta. Okay. Now in this, whatever values are known, you can substitute them. So what is the value of y? Y value is 30. X value we don't know. TC value, is it given? TC value, you can see it is given as 40. So take it and substitute 40. And TA value we need. Well, what is TA value? TA value is also given 84. So if you substitute all these, you can see Na value is 0. So this total has to be equal to 0. So only X is the only unknown here. So you can find X. What is the value of X?
63.25, sir.
So let's do the calculation quickly here. So 30 into 84 divided by 40. 63, huh?
Sir, 63.25.
There is no point now, no. Exactly 63 we are getting. Isn't it?
Yes, sir.
63. X value is 63. Okay. And now what is he asking? He is asking NB. So NB, what is the formula? NB formula is here. And you just need to substitute all the values here. So do you know the value of TB? Do you know the value of TB? Number of teeth on B, do we know?
No, sir.
We don't know. Can we find it? Can we find it? Yes, we can find it. So many times I discussed this method, yet you don't remember. So you see this total diameter, this total radius of the larger gear, and this is the radius of the sun gear, and this is the diameter of, F, diameter of B, and this is radius of C, and what about this total big one? This is radius of
Radius of A.
radius of A. Now what is the relation between all three? The relation is dB plus RC is equal to RA, correct? This is correct.
Yes, sir.
Now if I convert this into diameters, what happens? dB plus this is radius is half of diameter, no? Here also half of diameter, correct? Now we know the value called module. Value called module. What is module? Module is diameter by number of teeth. So what happens here? Diameter will be equal to module into number of teeth. Okay, correct? So this we need to substitute here. What happens? Here we get module into number of teeth on B plus module into number of teeth on C by 2 and same module into number of teeth on A by 2. So this module gets cancelled on both the sides of equation. And we get a relation between number of teeth on B, C, and A. So which of these number of teeth are known? TC is known,
TC.
that is 40, and TA is known. So both of them you can substitute, and you can find the number of teeth on B. What is the number of teeth on B? It will be TA by 2 minus TC by 2. So TA is 84, 84 by 2 minus TC, TC is 40, 40 by 2. So here we get 42, 42 minus 20, 22. Okay. So TB also we came to know. So now if you want to find the speed of B, the formula is y minus x into TC by TB. So substitute. What is the value of y? Y is known as 30. What is the value of x? X is known as 63. And what is our number of teeth on C? Number of teeth on C is 40. And what is number of teeth on B? Number of teeth on B, we just now found it. That is 22. That's it. You just calculate it, you will get it. What do we get?
So 22 or 20, sir?
So here what we are getting? Here we are getting 42. 42 minus 20, no? 42 minus 20, 22, no?
Okay, sir.
Correct? So the same 22 is coming here. Now do the calculation. What do we get? So 30 minus
84.5.
63 into 40 by 22. So minus 84.55. So what is the meaning of minus? What is the meaning of minus?
Anti-clockwise direction.
Yeah, anti-clockwise direction. Minus means anti-clockwise direction. Got it? Minus means anti-clockwise direction. And then that's it now. NC also is asking. NC also there is a formula. NC formula is x plus y. So just substitute. So x plus y. X value is how much? 63. Y value is 30. Add them. So you just get 93 RPM. That's it. Okay. Is this clear?
Yes,
Next,
sir.
any other doubts?
Sir, in the
Next 11th question.
slider crank mechanism,
One by one. Slider crank mechanism.
sir, if they ask the question, we should write for single slider or double slider, sir?
If he says slider crank, you have to write single slider.
Acha, means we should
If it
not
is
write
double slider,
slider.
if there is double slider, there is no crank. He will call it as double slider mechanism. Okay.
Yes, sir.
Double slider doesn't have any crank.
Okay, sir.
Yeah. Next question.
Sir, 11th question.
11th question from the question banker.
Yes, sir. Important question. This 11th.
So simple now. It's from the textbook only. Want me to solve? This is directly taken from the textbook. Many times this question has appeared in the exam. So how many are having this doubt?
Sir, me, sir.
You are also unable to do this. Okay. Let's see. Okay, so first we need to make the table, right? Let's start with the table. So first, what we need to take? Speed of the arm. So here the arm is in triangle format, triangle form. Don't need to worry about that. Then we need to take the sun, that is called as S itself. Then S is meshing with P, so we have to take P. And all the three P's, they are the same. We need not take them separately, because all three of them, this one, and this one, all three are meshing with the same two gears. So gear, they are meshing with S and A. Both of them are meshing with S and A. Okay. And also don't get confused, because two circles are given for A. They are not two different gears. They are both the same gears. Fine. He has just given the thickness of that. So internal of that will have some teeth. Okay. So yeah. So yes is meshing with P, and P is meshing with A. That's it. So now start one by one again. So initially we are taking the arm as fixed, and we are giving one rotation to the sun. What happens to the other gears? What happens to the other gears? We want NP. P is meshing with S. So NP by NS equal to minus TS by TP. So now here NS is equal to 1. That's what we have assumed here. So that's what we need to take. Okay. So what happens here? So this one we get it as TS by TP minus TS by TP. Next again NA we want to find. Now A is meshing with P. So NA by NP, and because the meshing is external, we have to take it as plus, and that will be TA by TP by TA, TP by TA. And then NP we have to take it this side. Fine. And NP value we know it, that is minus TS by TP. Fine. So what I have done is I have transferred it to this side. NP I have transferred it this side, and in place of NP I have substituted this equation. This equation I have substituted. Fine. So simplifying this, TP will get cancelled. I will be left with TS by TA. TS by TA. So next we have to give X rotations. Okay. So instead of one rotation, I need to give X rotations. So just get X gets multiplied. Okay. And then finally, we have to give Y rotations to the arm. So when you give Y rotations to the arm, Y rotations get applied for all of them, because all the gears rotate along with the arm. Along with the arm, all the gears will rotate. Fine. So they get multiplied. So these are the final equations. These are the final equations. Now check what is given in the diagram, in the question. In the figure given below, rotates. So what is rotating? Annulus A is rotating at 300 RPM. So what is annulus? Annulus means NA. So NA is given as 300, and direction is not given, so we can assume it as clockwise. Clockwise. And what else about the axis of the fixed wheel? Yes, which has 80 teeth. So what is having 80 teeth? Yes is having 80 teeth. Okay. About the axis of a fixed wheel, yes, which has 80 teeth. That means number of teeth on yes has been given as 80. Number of teeth on yes has been given as 80. Then the 3-armed spider is driven at 180 RPM. So speed of the arm is also given. Speed of the arm is also given. So speed of the arm is how much? 180 RPM. 180 RPM. Okay. Once again, here he has not told what is the direction. So again, I will assume it as clockwise. Determine the number of teeth required on the wheel P. So he is asking us to find number of teeth required on P. Okay. So let us start by substituting. So NA is given. What is NA formula? NA formula is Y minus X and TS by TA. That is given as 300. So, and one more value is given, that is Fixed wheel, yes, he is telling. Fixed wheel, yes means yes is also fixed. Yes is fixed means ns is 0. Ns is 0. Ns is 0 means x plus y is equal to 0. And then arm speed also is given. Arm speed means y. So y value is given as 180. So now using these two equations, we can find the value of x. X value will be minus 180. So x value is found, y value is found. X and y value both are known. So we can substitute that here. So y value is 180 minus of x value. X value is minus 180 into TS by TA. TS is given as 80 and TA is not known, right? Number of teeth on annulus is not known. So TA. So that is equal to 300. So now here TA is the only unknown. So find TA. What will be TA? TA will be 300 minus 180.
Sir, question they are asking TP, no sir.
Yeah, first we have to find TA and then TA we have to substitute here.
TA, however, where will use TA, sir? There.
So TA is not there in that, huh?
Hmm.
Okay. But we need TA to find TP. NP speed is not given, no? So this equation we
Yes.
cannot use. This equation we cannot use. We have to use the diameter formula again. So this is diameter plus this is radius, then total radius, you know?
Yes,
So
sir.
that we have to use. So first, that's why first finding TA is important. So find TA here. What do we get? I think it's coming out as wrong, huh? Are we getting decimal value here? 300 minus 180, 120. 20 divided by can that be TA? Something has happened here. What has happened? Okay, TA is going to numerator, no? So it will be reciprocal of this. So 80 into 180 divided by divided by 300 plus 180. So that is 120. So TA value we are getting as 120. Actually, this is 1 by TA. So the 1 by TA equal to this. So reciprocal of that we have to take to get TA. Okay, so TA we got it. Now TA and TS both are known. Once you know TA and TS both, now we have to apply the diameter formula. So first diameter of P plus what is this? This is radius of S. Radius of S can also be written as ds by 2. So ds by 2. So this is equal to total. Total is radius of A. Radius of A can be written as dA by 2. So dA by 2. So this can be, diameter can be replaced with module. So m times dp plus module times d, sorry. In place of diameter, what we need to take? Teeth. Again, same module into TS by 2 equal to same module into TA by 2. So here module gets cancelled in all of them, left and right side. So here 2 teeth are known. We can find TP, correct? So TP equals TA by 2 minus TS by 2. So TA is 120, 120 by 2 minus TS. TS is 80. So 80 by 2. So that means 60 minus 40, that is 20. Answer. Okay.
So thank you, sir.
Yes, sir. Thank you, sir.
Any other doubts?
Sir, question number 15 in 2020.
Sorry.
Question number 15 in 2020 question paper.
Question number 15, 1-5.
Yes, sir.
In question paper,
2020.
can you tell me the page number? Is it same
102.
PDF or different one?
This one only, sir.
Page number?
2.
Page number 2. Page number 2, question number
15, sir.
15. Mhm.
Diagram of the gear.
Diagram is not given here. So we have to
Yes,
draw
sir.
the diagram.
We have to draw.
Yeah, we have to draw it. Let us see. So there is a question. Okay, so internal wheel B is having 80 teeth. It is key to shaft F. Okay. Let us say this is the internal wheel B. Internal wheel B is 80 teeth is key to shaft F. So B and F are the same. B and F are the same. A fixed internal wheel C with 82 teeth is concentric with B. Okay, so these are the bigger ones, right? So we have to take the bigger circuits. So there are two internal wheels. There are two internal wheels, right? So B and F are same, and B is having 80 number of teeth. And then we have internal wheel C. So this one is C, internal wheel C with 82 teeth. 82 teeth. It is concentric with B. Then a compound wheel DE. Yes, with two internal wheels. D has 28 teeth and gears with C. Okay, so there are. Okay, so let me start. Let me take this point here, and so here one is meshing with this gear, second is meshing with this gear, right? So which gear? Compound wheel DE. So D has 28 teeth and gears with C. So this outer one is D. Outer one is D. It has 28 teeth and it is meshing with C. Correct? While E, so E is this gear. E gears with B. So E is gearing with B. The compound wheels revolve freely on a pin which projects from the disc keyed to shaft A coaxial with F. So again, now here we have an arm here. We have an arm here. Okay, we have an arm here, and this is the arm, and this arm is rotating at the same center as the other two gears. If the wheels have the same pitch, and shaft A makes 800 RPM, so that means speed of the A has been given. So speed of A is given as 800 RPM. So what is the speed of shaft F? So speed of shaft F, and F is same as B. So F, when he's asking F, we can just find the speed of B, and that will be done. Okay. If the wheels have same pitch. What is pitch? The wheels have same pitch. Same pitch means same module, I think. Same module, and the shaft A makes this much. What is the speed of the shaft F? Sketch the arrangement. So last part we have done. Sketch the arrangement. We have sketched it. Okay, so now we need to find what we need to find. What is the speed of shaft here? So NF or NB we need to find. Okay, NF or NB we need to find. Once again, we can do it the same way. Fine, we can do it the same way. So we have to start with the table. We have to start with the table. So first we have to take the speed of arm. We have to take the speed of arm. Okay, we have to take the speed of arm, and then we can start with one of the gears. So one of the gears we can call it as the sun gear. So let me just take it as NB. Fine, NB or NF both are same. Now NB or NF, that is meshing with E gear. That is meshing with E gear. So let me take E, and then E and D are compound. E and D are compound. So whatever is the speed of E, same will be the speed of D. And then D is meshing with C. D is meshing with C. So NC we have to find at last. So first again we are taking arm to be fixed. We are keeping arm fixed, so 0. We are giving one rotation to NB or NF. And then we need to find NE or ND. So now NE, okay, so NB is known. B is meshing with E, so we need to find NE. NE by NB will be equal to TB by TE. And once again, because this is internal meshing, meshing is internal, so this will be positive. This will be positive. So now NB value we are taking it as 1. So NE will be same as TB by TE. TB by TE. And same way we need to find NC. So to find NC, C is meshing with D. C is meshing with D. So ND. This is equal to TD by TC. Once again, this is also internal meshing. This is also internal meshing. So again, this is to be taken as positive. Now, okay, ND and NE both are same. So ND and NE both are same. So ND, take it this side and substitute for NE. So NE is nothing but TB by TE. TB by TE. So here nothing is getting cancelled. Nothing is getting cancelled. So we have to keep it as it is. So we have to keep it as TD into TB divided by TC into TE. Okay. This one we have to do. I think in class I have done it slightly differently. And in the class I have done it slightly differently. So both ways we can do. The final answer we will get the same. Fine. So next you have to multiply x throughout. Multiply x throughout. TB by TE. And here also multiply x, TD, TB, TC, TE. And then we need to add y. So here also add y, here add y, and add y, and y. Right. So these are the equations. These are the final equations. Now we need to use these equations and we need to find whatever is asked. So NA, what is A here? A is not there. Shaft A. If the wheels have the same pitch and shaft A is making 800 RPM. So shaft name is A, and the shaft A is keyed to on a pin which projects from a disc keyed to shaft A. The compound wheels revolve freely on a pin which projects from a disc keyed to shaft A. So that means the arm itself is connected to shaft A. When I say NA, that is same as N arm. That is same as N arm. So N arm means the formula for N arm is Y. So Y value has been given as 800 RPM. Okay, Y value has been given as 800 RPM. And any other speed is given? Internal wheel B with speed to shaft here. fixed internal wheel. He is telling fixed internal wheel C. That means the speed of C is 0 because this is fixed. Okay. So what is the formula for CNC? NC is formula is here. So X times TD into TB by TC into TE plus Y. This is equal to 0. So now here all the number of teeth are known. TD is known. TB is known. TC is known. TE is not known. T number of teeth on E, is it given?
No, sir.
Can we find it?
Yes, sir.
How can we find it?
TB by TE.
Sorry.
TB by TE we cannot do now, sir.
1 minute. Let's take diameter of C by 2. Diameter of C by 2. This is the total length. Diameter of C by 2 is the total length. And okay, this is confusing, right? Yeah, so diameter of C by 2 minus diameter of minus diameter of E by 2. Okay, so we have reached here, this point, right? Now same point we will reach by taking diameter of B by 2 minus diameter of B is meshing with E, this is meshing with D, so here it should be D, here it should be D, here it should be D, here it will be E by 2. B is meshing with E, C is meshing with D, so C minus D, B minus E, so this should be equal. So this relation we can convert into module. So module is same for all of them. So by 2 will also come out. So TC minus TD will be equal to, here also module by 2 will come out, TB minus TE. So module will cancel on both sides. And with this we can find TE. So TE will be TB minus TC plus TD. To do this, TB is how much? 80. Minus TC is how much? 82. Plus TD is how much? 28. What do we get? What do we get? 80 minus 82 plus 28 is 26. So TE is 26. So now all these values are known except X. So find X. So X will be minus of Y into TC into TE by TD into TB. So substitute. So minus Y is 800. TC is how much? TC is 82. TE is how much? TE just now we found 26 divided by TD. TD is how much? TD is 28 into TB. TB is 80. What do we get? X value? X value, what do we get? Minus 800 into 82 into 26 divided by 28 divided by 80. So we're getting minus 761, minus 761.43 RPM. Okay. So this is the value of X. This is the value of X. This is the value of X. This is the value of Y. This is the value of X. And what is he asking? He's asking NF or NB. So we want to find X plus Y. That's it. NF equal to NB, that is equal to X plus Y, right? So minus 761.43 plus Y is 800. What do we get? So here just need to plus 800. 38.57 RPM. That is clockwise. Got it? This is our final answer. Is it clear? Are you getting my sound?
Yes, sir.
Yes, sir.
Is
Yes,
it
sir.
clear?
Yes, sir.
Yes, sir.
In the class, I think I have followed a slightly different approach, but I think I have got the same answer.
Yes, sir. Yes, sir.
Did we get same answer?
Yes, sir. Yes, sir.
Okay. That's
Before
what. So
level
method
question.
doesn't matter. Method doesn't matter. You just have to make the table. Once the table is ready, then you can easily get it. Okay.
Sir, from the important fifth one.
Important fifth long answer, huh?
Sir,
Yes, sir.
before that, I have sent WhatsApp gateways only. Just the table you
Sorry.
this one, sir. Just the
So inside, I think I have shown us disk now. So that disk is nothing but the arm itself, and that is not on the inside. That has to be larger one. Okay. Is it the same question that we solved just now? No, this is a different one. No,
Different, sir.
this is different one. From where you took this?
yes, sir.
This question is from which book
I
you took
got
it?
from other material, sir.
From other material. No?
Yes. That
Okay, shall
compound gear is there, sir. DE. So
D
little
is
bit
compound.
confusing in that.
D
compound.
D is compound.
Yes.
Okay, let us
Yes.
try this. Copy image. Okay. So here, this is the epicyclic gear has been drawn correctly. So we just need to make the table. So I'll just create the table and leave it at that. Okay. Is that okay?
Yes, sir. Just the table.
So we have to again start with arm. Then here the central gear is C gear. That C gear is meshing with the D gear, and D is same as E because both are compound. Fine. Because both are compound, we have to take them as single gear. And then finally that is meshing with G gear, right? So again here this we should take it as 0. Then NC, C is meshing with, sorry, we have to give one rotation to C, no? One rotation to C we have to give. We have to give one rotation to C. Then we have to find ND. So ND, D is meshing with C, and it is meshing externally, so minus TC by TD. Now NC we are taking it as 1. The ND will be minus TC by TD. Then we need to find NG. NG, that is meshing with E. So NG by NE, that should be equal to positive. Why positive? Because it is meshing internally. And that will be TE by TG. TE by TG. Now NE will be same as ND. Fine. And ND, we are substituting its value. ND is equal to this. So minus TC by TD. Okay. So that's what comes here. So minus TE, TC by TG, TD. Then we have to multiply x throughout. So into x, into x, into x, and then add y. Fine. So add y, and add y here, add y here. That's it. So this is the formula. Okay, this is the formula. And here we will get x plus y. This is the formula. So this is just y. Okay, so these are the formulae. These are the formulae. Okay. So now you just need to see what is the given data. You have to substitute and find whatever is not given. That's it. Is it clear?
Yes, sir,
Please
thank you.
say friction problem, sir.
Which one?
Sir, sixth one.
Question banker.
No, sir, from important questions.
Important question. Sixth question.
Sir, how to find mass density, sir?
Mass density is given now here. Mass density
Sir,
is
means
given.
which formula we have to apply?
I think centrifugal force we can find using that. No,
Sir, not getting, sir.
we can leave it in option now. Most of the other ones we have covered. No,
Yeah,
this one
okay, sir.
belt drives are slightly confusing even for me. Fine. So
Sir, fifth one, the above one.
fifth one is velocity and acceleration. So this is a, for this you have to draw diagrams, velocity and acceleration diagrams. Are you sure you want to do this?
Yes, sir.
Okay. So we'll have to again take this. I'll have to do it in AutoCAD. All right, let me take this question. All right. Mm, Okay. The configuration of slider crank is shown. We have to find acceleration of the slider at D and acceleration of the point E when OA rotates at 30 radians per second counterclockwise. Okay. We need to draw this first, right? We just need to draw this first. Okay, so I need to take a horizontal line. Then I need to take a line at 60 degrees. What is the length? Length is 480. So 48 mm I will be drawing. Fine. So I'll be drawing 48 mm at 60 degrees. Okay. And then from here, I'll be taking 160 mm. It's appearing very, very small, but on your page it will fit correctly. Okay. On your page it will fit correctly. In fact, this has become very, very large. So let me reduce this. Somewhat like this, right? So this is your position diagram. This is your position diagram. Okay. And it is extended on back side. Length extended by how much? 45. 45. All right. This length is 45. Yeah, this length is 45. This length is 16. This length is 48. Okay. So this is how we have drawn it. Now once the position diagram is ready, we need to next draw velocity diagram. So for velocity diagram, I have to first find the velocity of point A. What is the velocity of point A? Okay, I think I have to use both these I have to use here. Mhm. Velocity of A with respect to O, this will be the angular velocity into length OA. Okay, so angular velocity is 30. That is already given in radians per second. It's already given in radians per second. So 30 multiplied with OA. OA length is 480 mm. So 480 mm. So for this mm, we need to convert it into meters. So milli is 1000. So that's what we get. So let us calculate this. What do we get? 30 into 480, 14.4. 14.4 meters per second. 14.4 meters per second. Okay, so this is the velocity of A with respect to O. So A with respect to O. Velocity of A with respect to O. So this velocity, when we are drawing it in the velocity diagram, we have to represent it by some length. So I will take it as 50 mm. Okay, and it will be perpendicular to this length. So I will have to take this perpendicular, and this length I have to take it as 50 mm. And so length total, so 50 mm. So this line is perpendicular to this line, and it is length is 50 mm. Now because it is rotating anti-clockwise, okay. So this point becomes O. This point becomes O. This point becomes A, and this point is capital O. This point is capital A. This point is capital E, and this point is capital B. Okay, so position diagram use capital letters, and velocity diagram use small letters. Okay, so this length we got it. So next, the slider will be moving horizontally. Slider always moves horizontally. Okay, slider always moves horizontally. So this is the direction of velocity for B. And next, the velocity of B with respect to A. Will be perpendicular to this. So I have to copy this. So this perpendicular. So these two should meet. So where do they meet? They meet at the point B. Now, this is the velocity of A with respect to B, or B with respect to A. This is the velocity of B with respect to O. This is the velocity of A with respect to O. Once we got all of these, we have to next find the point E. So for finding the point E, we have to take it in the same ratio. It should be in continuation of B, A, and then E. So here also B to A, and A, from A we have to extend this line to get the next point, that is E, and it should be in the same ratio. Fine. So in AutoCAD, I'll just take it quickly, but when you are doing it on the paper, you will have to calculate. Fine. You have to use similarity theorem to reduce it. So I'll just use scale operation. Okay, so I'll have to reduce it by the same ratio, and this point A is coming here, and this point is fine. That point is E. So velocity of E with respect to O, if you want, you can get it like this. So this is the velocity diagram. This is the velocity diagram. Once you know the velocity diagram, then you have to go for acceleration diagram. Now, this link is rotating with constant velocity. That link is rotating with constant velocity. So, acceleration of A with respect to O, it will be sum of two accelerations. So first is the centripetal acceleration of A with respect to O plus the radial or tangential acceleration of A with respect to O. So because the velocity is constant, this value will become 0. And the value of centripetal acceleration, what is the value of centripetal acceleration? Anyone? Centripetal acceleration, what is the formula? Omega square into AO. What is omega? Omega is 30. So 30 square into AO. AO length is how much? AO length, what is AO length? 480. 480 mm. 480 mm. So this milli we have to remove. Milli is nothing but 1/1000. So do this, you will get centripetal acceleration. How much is the centripetal acceleration? Okay, let's do the calculation. So 30 into 30 into 480 by 432. So 432 meters per second square. So this is the centripetal acceleration of A with respect to O, and it is also equal to total acceleration of A with respect to O. So when we are drawing this, again we should be able to conveniently draw this. So I'll just take it as 50 mm. And I'll have to mark it as O dash A dash. Fine. And what will be direction? It will be parallel to OA. So it should be parallel to OA. It should be in this direction. Okay. And its length, I'm taking it as total length. I'm taking it as 50. Now you can see its total length is 50, and this point becomes O dash. This point becomes A dash. Fine. So we are using dashes for acceleration diagram. We are using dashes. So that is the total acceleration. Next, we need acceleration of B. Fine. So acceleration of B with respect to fixed point, that is O. That is again sum of two accelerations. That is centripetal acceleration of B with respect to O and tangential acceleration of B with respect to O. Now in this case, centripetal acceleration will be 0. And we just need to find tangential acceleration. So we don't know the value of this, but we know the direction. Direction will be parallel to OB. So that I will just draw it here because it is horizontal. So it will be horizontal. So this is the direction of the acceleration of slider, but we don't know where the point lies. Hence, we have extended it on both the sides. On both the sides. Next, let us find acceleration of A with respect to B or B with respect to A. Okay, acceleration of A with respect to B or B with respect to A. So acceleration of A point is known, so A, okay, or B with respect to A. b with respect to a. So this total acceleration, again, we can split it as centripetal acceleration plus tangential acceleration. Okay. So now in this case, it will have both the accelerations. It will have both the accelerations. So let us first go for centripetal acceleration. So centripetal acceleration of b with respect to a, this will be equal to omega of ba, or square of this into ba. Okay. So omega of ba, we need to find omega of ba. How to find omega of ba? For finding omega of ba, we have to use velocity of b with respect to a. Velocity of b with respect to a divided by ba. And velocity of b with respect to a, we can get it from this diagram. So we have to get it from this diagram. So let us take that. We're getting 25.89. So we have to go back to our velocity equation. So we are getting the velocity of b with respect to a, that we are getting. So that we have to get, actually, that we have to get. And what we got right now, is the length AB. The length AB. AB length is 25.9. I'll just round it up to 25.9. And this I need to convert. Into velocity. So for converting, what I have to do? I have to take this value 25.9, and I need to apply the same ratio here. This value is in mm, so into 14.4 divided by 50. So this ratio I need to apply. So that ratio when I apply, we will get velocity of b with respect to a. So take it 25.9 into 14.4 divided by 50. So 7.46 meters per second. So this value we need to take here. Velocity of b with respect to a. What is that value? 7.46 divided by BE. What is the length BA? BA length is 1600 mm. So it will be 1.6 meters. So when you do this, what do we get? 7.46 divided by 1.6. 4.66. Now this is in radians per second. And this value we need to use here to find centripetal acceleration. 4.66 square into BA. So BA length is 1.6. What do we get here? 4.66 into 4.66, that is square into 1.6. So 34.74 meters per second square. Okay. So this is the value. So now b with respect to a, so that will be in this direction, in upward direction, and it will be parallel to AB. So let me take this parallel to this, and it will be b respect to a. It will be going in this direction, and its length. What should be its length? For 432 length, for 432 meter per second square, 432 meters per second square, we took 50 mm. So for this, how much? So for this, we have to take this as length a dash to b of a. this is the length you have to take, and you have to take it in the ratio. So 34.74 into 50 divided by 432. This ratio if you take, you will get the length. So what do we get? 34.74 into 50 divided by 432. That's 4.02. 4.02 in mm. So you just have to take it as 4 mm. So length total 4 mm. So it's a very, very small length. It's a very, very small length. And this point is B. This point is BA. Okay, this is a temporary point. BA. Next, the tangential acceleration. Tangential acceleration will be perpendicular to this. So I need to take perpendicular to that. So let me take this, rotate perpendicular to that, and that line I need to touch here. Okay. So now we are getting some intersection. So that intersection point is what we wanted. Okay, so this point that we got, that point is B dash. Okay, so that gives us the acceleration. So OB, yes, OB is the acceleration. So by measuring this, we will get the acceleration. That is 17.49. So acceleration of the slider. So therefore, acceleration of slider, that is B. That is equal to the length O dash B dash. That needs to be multiplied with how much? You need to convert it back into meters per second square. Right? So we need to multiply it with 432 and divided by 50. O dash B dash is how much? O dash B dash is 17.5 into 432 divided by 50. So what do we get? 17.5 into 432 divided by 151. 151.2. So this is the value of acceleration in meters per second square. Okay. So this is how you need to find. So now A bit is over. Only A bit is over till here. We need to find B bit also. B bit is acceleration of point E. Acceleration of the point E. So to find E, we have to extend AB. So take A to B. So now A dash B dash, we need to extend in the same ratio. So once again, I will need to draw this. Fine. So you have to, of course, calculate it, and then accordingly you have to do it. This has to be extended from the end A. The end A is extended. Fine. So then I will scale it. So this point. This point is A, and this point that we got, that is E dash. So that E dash, if we are connecting with O dash, so that will give us the total acceleration of E. So this value is 61.7. Okay. So from acceleration diagram, so acceleration of E with respect to O, that is equal to 61.75. So this is in mm. This is in mm. You need to multiply it with 432. Multiply with 432 meter per second square and divided by 50. Cancels. We are going to get the value in meter per second square. Okay, so let's do it. What is this value? 61.75 into 432. So 533. 533.5 meters per second square. So this is the value for dB. Okay. So very complex, and you will need a lot of practice if you want to do this. You need to do a lot of practice to do this. Is this clear? So this part you have to draw it on the drawing sheet. You have to use drawing sheet along with all your instruments. You have to draw this. You have to take the measurements from here, and accordingly you have to do the calculations to get the result, final result. Is it clear?
Drawing sheet, sir.
Yeah, drawing sheet. You have to ask them. Many colleges don't know that there is a subject which requires drawing sheet. Fine. So as soon as you get the answer script, please request them. Ask them. You have to tell the invigilator that, sir, this subject requires drawing sheet. Okay.
Okay, sir.
So only if you ask, they will provide. If you don't ask, they will not provide it.
Okay, sir.
So better ask as soon as you go into the exam hall. As soon as you get the answer script, ask the invigilator, sir, we need drawing sheet. If he says it is not provided or something, then you can call the in charge. All of you should stress it. All of you should stress it. Even if you don't want to use the drawing sheet, some students will not want to draw the don't want to solve the diagrams. They also should support. Fine. Everyone should support. Everyone should ask together as a single voice. Then they'll definitely provide it. Okay.
Okay, sir.
In that drawing sheet, you have to attach it with your answer script.
Okay, sir.
Any other doubts?
No, sir.
Krishna, any other doubts? So I'm sharing this also. Any other doubts?
No, sir.
Okay. All the best for your exam tomorrow. Study neatly, study nicely, and score maximum. Okay.
Okay, sir. Thank you.
Okay. Good night then. Bye.
Bye, sir. Bye.